All right, good evening, ladies and gentlemen. I want to welcome everybody that's here in the room and also especially everybody that has joined us online. So all the guests, thank you very much for being here. So my name is Wikus van Niekerk. I'm currently the Dean of the Faculty of Engineering, and at this time I'm also acting as the Director of the Center for Renewable and Sustainable Energy Studies, which is a co-host and a co-sponsor of the event this evening. I specifically want to welcome the following colleagues. First, Professor Stan du Plessis, the Chief Operating Officer of Stellenbosch University, and especially today in his role as Acting Rector and Vice Chancellor, because Professor Wim de Villiers is on his way back from Japan. He wanted to be here, but he had more important things with the choir and other people in Japan. So, we will send him the recording. But Stan, thank you very much for being here. Professor Bismarck Toyobeka, who's the Vice Chancellor of the Northwest University, is on the panel, but he's still 2.5 kilometers away. Now in Stellenbosch, if you know the traffic, 2.5 kilometers is quite a way to go this time of the afternoon, but he will soon join us. We also have Professor Edward Kiramura here, the Director of STIAS, which also a co-host and a co-sponsor. Edward, thank you very much for being here this evening. Then we have the two presenters on the nuclear tour, Andy Karlitz and Peter Prusetsky, who sits in London, and you can see on screen there, so welcome to you. And then also the other two panelists who are fortunately here already, which is Professor Mark Swilling and Ms. Jessie Burton. So thank you very much for being here. I'm not going to read any CVs. The bios were available in the invite, and they are actually still on the meeting request. So if you want to see how well versed these colleagues are in talking to us about what they're going to discuss today, you can read it there. The participants, the audience, were invited based on your contribution and interest in energy and electricity in South Africa, as well as your knowledge of the nuclear power industry. So it wasn't really open to everybody. We kind of selected certain people to come, and then, of course, there were other people nominated, and then we said, no, that's fine. The purpose of this nuclear power dialogue tonight is to provide a perspective on the South African decision to expand nuclear electricity capacity in the country. We have chosen to put nuclear power under the magnifying glass, not the comparative merits of nuclear, gas, coal, and renewables. That is a different discussion with a different audience, right? So we know that other sources of power will be raised at some point, but this is not really the intention. The intention is to really discuss nuclear power, contribution that nuclear power can make to South Africa. Nuclear power in South Africa is important to both the University of Stellenbosch and the University of Cape Town, as we are located 70 kilometers from Coburg. I don't know if that's a good or a bad thing. But we train engineers, scientists, and economists for the South African energy sector. So we really also have a stake in what happens in the nuclear power sector going forward. And our session today is set in 3 parts. We're going to start with an international tour, and that will take approximately 40 minutes, and that will be presented by the two gentlemen on the screen. After that, we have a panel discussion, and then after that, we're going to open the floor and the screen for questions from both people in the room, but also specifically our colleagues online. So with that, I'm going to revert to our colleagues in London. And both of them are South Africans with considerable international energy and nuclear experience. And we're going to ask them to take us on a nuclear power tour with some takeaways for South Africa. Thank you very much.
Because can I check that you can see my screen? Peter, can you see my screen?
I can see your screen.
Yeah, okay. We can see your screen and we can hear you, Andy.
Thank you very much. Good evening from London, and delighted to be with you on a very important subject internationally, but also a very important subject for South Africa. We start our journey tonight at Coburg, 65 kilometers from Stellenbosch, where this power plant below us has, since 1984-85, when it was commissioned, played an important role. And for those who are not familiar with nuclear power plants, There you can see the two reactors, you can see the turbine hall, the cooling water inlet, and the warm water outlet into the Atlantic Ocean. And these two pressurized water reactors of 1,800 megawatts have contributed about 5% of electricity supply in South Africa for quite some time now. And as we heard this morning in a conversation with Premier Wind, preparations are on the go for extending the life of Koeberg and applying for a license to that. But let's tonight go and see where the world's nuclear power plants are located and visit some of them, as we remember that the World Association of Nuclear Operators, International Atomic Energy Agency, and the Nuclear Energy Agency oversees the world nuclear industry. And Peter, it's about the country with the largest nuclear program in the world that you know so well.
Right, so moving to the US then, main electricity source is obviously natural gas in the US, but they are the world's largest producer of nuclear power with 93 reactors operating in 30 states. They already have 41 reactors that are decommissioned, and those 93 reactors provide about 18% of electricity generation in the US. And that also means that they provide the largest source of low carbon electricity in the US, mainly pressurized and boiling water reactors, but they are now also developing some more advanced reactor types. The first commercial plant was online in 1957, and unfortunately, as a result of 3 Mile Island accident in 1978 and the Fukushima accident in 2011, that really contributed to public resistance to nuclear power growth over the years. In recent years, several plants have had to shut also because of some of the economic challenges, largely brought on by natural gas competition and the emergence of some renewables. Also, life extension, which is required by license in the US after 40 years, has also proved quite costly to some operators. There had been a long hiatus in building new plants in the US, principally after TMI, but 2 projects were started in the early 2000s, and I'll come back to those shortly. And currently, small modular reactors and advanced modular reactors are being developed and tested, and they herald a new future, really based on improved economics and time to market for those technologies. One of the key open issues in the US at the moment is still storage and disposal of spent fuel. There is no national repository at the moment, and reprocessing is not permitted. I'd like to take us to a couple of those red dots that you see on the picture. The first station I'm going to look at is Palo Verde, and that's located in Arizona, close to Phoenix. And it's the largest single site in the US. It has 3 pressurized water reactors, 3,940 megawatts approximately installed capacity. And what's quite unique about the site, as you can see from the dot on the right-hand side, is they utilize treated wastewater from the local cities being in the desert. They utilize that water for cooling. And Palo Verde supports about 4 million people, customers in Arizona, California, and Texas. It started operating between 1986 and 88, and it's owned by Arizona Public Services Company and a few other minority shareholders. I'd like to go to Vogtle next. Vogtle Electric Generating Station is in Georgia. 2 principal owners are Southern Nuclear Operating Company and Georgia Power. There are also another few minority shareholders as well. And the 2 initial units, which you see on the left-hand side, were started in the 1980s and were 1,215 megawatts capacity each. Units 3 and 4 are the new Westinghouse advanced pressurized water reactors, AP1000s, and those are the 2 right-hand red dots that you see on your picture. Unit 3 went into commercial operation last week, and Unit 4 also recently received permission to load fuel. And both of these units, these new builds, had quite a difficult contractual birth. I'd like to go to VC Summer next, near Jenkinsville in South Carolina. And their first unit here, the one shown in the dot, is 1,000 megawatt PWR, and it's owned by Dominion Energy and South Carolina Electric and Gas Company. It's operated by Dominion, and the shareholders decided to expand by building units 2 and 3. However, the plans were cancelled in 2017. Lots of contractual disputes based on escalating costs, construction delays, and actually led to the bankruptcy of the supplier, which was Westinghouse. And this plant has seen significant legal and financial fallout for both the supply chain and the future owner. So let's look at the US electricity generation for a week in April and May. And natural gas still remains the largest source, as I said in the beginning, followed by nuclear. And you can see wind is now approaching the same sort of levels as coal generation these days. And at the bottom, you see solar and hydro. So I'd like to move to some takeaways for South Africa based on the American experience. Initially, you saw the events at TMI cause that hiatus in growth, and then subsequently cheap natural gas and expanding renewables have become a strong factor. The experiences with VC Summer and Vogel have really put private investors off on, building new large projects. And as I say, the immediate future appears to be in the hands of SMRs and AMRs, with some contracts already having been signed with plans to put units on the grid probably in the late 20s or early 1930s. I'd like to move away from the USA to the rest of North America, then quickly just touch on Canada. And, they're blessed with significant hydroelectricity generation as their primary source, but they have several reactors at sites like Bruce, Pointe-le-Pro, Darlington, and Pickering. And collectively, these plants contribute 13% to electricity generation in Canada. Their reactors are local design, pressurized heavy water reactors. The advantage being they can be fueled by natural uranium without enrichment, but obviously require a heavy water plant, which in itself is a complex technology. They are also actively pursuing SMRs, and they have also just recently signed some contracts for development and construction on some sites in Canada. Mexico is heavily reliant on natural gas and has one operational site at Laguna Verde on the Gulf of Mexico. And there they have 2 boiling water reactors with a combined output of 1,650 megawatts. And that contributes about 4% of the country's generation. Moving down south to South America, Brazil, again, also blessed with abundant hydro in that Amazon basin. They have 2 operational reactors at Angara. Unit 1, built in 85, about 640 megawatts installed capacity. And Unit 2, a 1350 megawatt reactor, was put online in 2001. Angara 3 is under construction at the moment. And nuclear contributes about 3% of generation in Brazil. Argentina, reliant heavily on natural gas for generation, and they have 3 operating reactors based at 2 sites, so the Atucha and Embalse sites. Atucha 1 and Embalse contribute about 12% of electricity generation, and Atucha 2 another 7% from its 745 megawatt unit. And Argentina is also developing some indigenous an indigenous 30 megawatt prototype reactor. So let's go to the country with the most comprehensive nuclear power program. Andy, take us to Russia.
Thank you, Peter. In a very cold country, Russia, natural gas is the largest source of electricity and energy in the country. The first nuclear power plant in Russia was already built in 1954, and it's now a museum outside Moscow. But today, Russia has 37 operable nuclear reactors at 10 nuclear power plants and a total capacity of 28 gigawatts of capacity online. And they together generate about 20% of Russia's power. And you can see them reading from the top, the Kola plant, the Leningrad plant, Kalinin, Smolensk, Kursk, Novovoronezh, Rostov, Balakovo, and Belyarsk. And all those generally named after the places where they're located. A government decree in 2016 said that there will be 11 new nuclear power reactors by 2030. And so those are currently under construction, or 3 of those are currently under construction, with about 3 gigawatts of capacity between them. And the strength of the Russian nuclear industry is reflected in its dominance of export markets for new reactors. And as we will see later, the national nuclear industry through Rosatom is currently involved in new reactor projects in Belarus, in China, in Hungary, in India, in Iran, in Egypt, in Turkey, and in Bangladesh. Let's visit the 2 sites that you see marked on your screen in red, the Leningrad project outside St. Petersburg, and also a special nuclear plant in the Russian northeast, the academic Lomonosov. And below us, we see the Leningrad 2 nuclear power plant in St. Petersburg. It's a modern VVER, or water pressurized water reactor. Russians consider that safer and more efficient. It has 2 units, each with a capacity of 1,200 megawatts. First one was already commissioned in 2018, and the second one is being commissioned this year. So that's what a Russian nuclear power plant looks like. I also take you, as you can see on the little map on the bottom left of your screen, to a place called Pevek. It's a port on the Russian northwest on the new coastline, cruise line to Asia. And at that red dot, you see the world's 2nd floating nuclear power plant, which is constructed by Russia. It consists of a non-propelled power barge with 2 modified naval propulsion reactors. And together they can generate from that floating barge 70 megawatts. And if you want to know what that looks like, at the red dot, you can see the academic Lomonosov anchored in Pevek port. What would be my 3 takeaways for South Africa from Russia? The first one is that Rosatom, building on that domestic experience, is the world's biggest nuclear power technology exporter, supported by intergovernmental loans. Secondly, that Russia has a fully integrated nuclear power capability, covering research and design and construction and operation and enrichment. And lastly, that Russian nuclear power is fully state-owned with strong links to military applications in that country. Peter, why did you take us to the country that is most reliant on nuclear power?
Right, Andy, thanks. The 3rd largest producer behind USA and China is France, with 62% of French electricity being generated. So they're the 3rd largest producer in terms of annual gigawatt hours, but in terms of capacity, 62% of French electricity comes from the nuclear stations. They started rapid expansion really after the 1970s oil crisis. And if you want a lesson on how to build plants quickly, France certainly did that in the 70s and 80s. They have 56 operating reactors on 19 sites, and total installed capacity there now is 61 gigawatts. They have 1 reactor under construction at Flamanville with 1750 megawatts, and I'll come back to talk about Flamanville. As you can see, the red dot on your chart, the left-hand red dot. I'll come back and talk about that. EDF, Électricité de France, is the state-owned company, and they obviously own and operate all plants in France. France has a self-contained nuclear fuel cycle, through all stages of fuel manufacture, enrichment, manufacture, reprocessing, and have had a good safety record over the years that they've had plants, with no major incidents to date. They've also been exporters of the technology, as you know, to South Africa, but also to Belgium, South Korea, China, and latterly now also to the United Kingdom. Some of the early plants have been decommissioned, and there were a variety of those plants, also some gas-cooled plants and fast breeder reactors and so on, but those have all been decommissioned. There was a government policy to reduce dependence on nuclear power to 50% a few years ago, but that has now been reversed and postponed as a result of the Russian-Ukrainian war, which is ongoing. Over the years, there's been some opposition to nuclear, but current public sentiment is positive, and the government has recently announced 3 new nuclear sites for building the new EPR2 design of plant. I'd like to take us to Gravelines, which is close to Dunkirk, and it's the northernmost French plant, 6th largest nuclear power plant in the world, 5,460 megawatts of installed capacity, and they have 6 920 megawatt units, and it is the largest plant in Western Europe. Commissioned between 1980 and 85, and it's the same design and generation of plant as the Koeberg plant. Let's move to Flamanville, and you can see the Flamanville site on that picture. The first 2 units are the right-hand dot, and the had 2 1,300 megawatt pressurized water reactors, which were built or brought online in 86 and 87. And Flamanville 3, which is the new reactor, which is currently still under construction. It's the only EPR in France, as I said, 1,650 megawatts. And it's similar to the Olkiluoto plant in Finland, the one which is being built at Hinkley Point C in the UK, and those that were built and are currently operating at Taishan in China. The initial commercial operation date was supposed to be 2012, but the project has seen, quite extensive delays. A lot of design problems initially. There were some construction issues. It's quite a novel construction techniques were being tried, and a few regulatory hurdles. Plant is still not running, despite the sister designs in Taishan and Olkiluoto, which are already up and running. And, it's a Generation 3 Plus plant, which has enhanced safety levels. But EDF is now planning in EPR2 design, as I said earlier. It's a somewhat simpler design, and that's really based on the lessons that they've learned from Flamanville. EDF is proposing this EPR2 design to international clients in India and so on. Look at a power generation graph a day in May 23, and you can see the significant baseload role played by nuclear. It's the red dot or the mustard color in that picture. And because of this big baseload slice in the daily energy mix, some units are equipped to partially load follow as well. Let's look at carbon intensity. And as you can see, France, next to the red dot over there, is one of the cleanest in Europe, which is only really surpassed by the Scandinavian countries, which are heavily hydro reliant. And so I'd just like to take us to the takeaways for South Africa. I guess, the clear thing is large-scale nuclear is significant in reducing greenhouse gas emissions. And France had a rapidly expanding program in the 70s and 80s. But the industry lost its capacity and ran into difficulties in executing these more modern and complex designs more recently. So we're speaking to you from the UK tonight. Andy, what can you tell us about a country that relies on foreign companies to build and own its nuclear plants?
Peter, the United Kingdom relies on gas for most of its power generation and operates 9 nuclear plants, and you can see them: Dungeness, Hartlepool, Heysham, Hinkley Point, Hunterston, Sizewell and Torness. And together those nuclear plants operate 14% of the country's electricity generation, and the country's been running nuclear since the mid-1950s. And the UK government's ambition is to more than triple Britain's nuclear power generation by 2050 from their current capacity. The Climate Change Committee, which advises ministers, said in June that the UK's progress on cutting emissions was worryingly slow. And so Britain has just launched a new program to add 24 gigawatts of nuclear capacity. Today, Britain has a nuclear workforce of 65,000, and that will need to more than double to support that. And this month, Britain launched the Great British Nuclear Program to oversee nuclear development in the country. Let's go to one of the most talked about construction sites for nuclear in Europe, which is Hinkley Point, where you see that red dot. And we look down from space, firstly at there are 3 power stations on the left, the old Hinkley Point A, which contained 2 Magnox reactors, but they've been decommissioned. And then Hinkley Point B, which was an advanced gas-cooled reactor. That is started its decommissioning in 2022. But up for conversation today is Hinkley Point C, which is the first new nuclear power plant to be built in the UK in over 20 years. It will have 2 of these EPR, European Pressurized Water Reactors, that Peter spoke of earlier, with 3,200 megawatts of capacity. And interestingly, it's being built by EDF of France and the China General Nuclear Power Group. And given the political stress between the UK and China, the UK is now seeking to exit the Chinese, but that's quite difficult halfway down. And once completed, Hinkley Point will provide about 7% of the UK's electricity. And let me just zoom in on that red dot for a moment, just tell you what that site looks like today in July. And you can see this sheer civil and mechanical and electrical complexity of a nuclear power plant site under construction. We see quite clearly yesterday that on the daily load curve, our nuclear runs right at the bottom, that grey bar flat in the UK. And we can see over how gas in orange and wind in blue kind of make up the demand profile over the days of 2022 in the bottom picture. And I think for me, the 3 takeaways for South Africa from the UK, Peter, would be that the UK as a G7 country is now relying on China and France to build and own its next major nuclear power plant, and build and own it, not just build it. The second one is that all nuclear power plants are now French government owned or government underwritten by the UK, France and China. And that nuclear provides base supply, gas-fired power provides the counter for the intermittency of solar and wind in the UK. And Peter, I'll just move on across back to Europe, where you were a moment ago, and remind ourselves that in addition to France and the UK, there are nuclear reactors in Belgium, in Netherlands, in Sweden, in Finland, in the Czech Republic, Slovakia, Hungary, Slovenia, Romania, Bulgaria, Switzerland, Spain, Armenia, and last but not least, Ukraine. And overall, the European generating mix from these 104 operating nuclear reactors is 39% renewables, 39% fossil fuels, and nuclear 22%. And the nuclear has just been included in the European Green Taxonomy for energy, not without its own controversies in getting there. Let's visit one of those stations, which is the Ukrainian station of Zaporizhzhia, because it's so much in the news in the past year. It's the largest nuclear power plant in Europe. 6 nuclear reactors that you can see where that red dot is, generating 6,000 megawatts. That was captured by Russian forces in March 2022 during the invasion. The IAEA is watching it, concerns about nuclear safety. To my knowledge, the plant is currently under control of Russian forces. Ukrainian operating staff are still operating it. Peter, let's conclude the European piece by going to Germany just next door. Tell us about the fully stopped nuclear power program.
All right, thanks, Andy. I guess one of the interesting facts which emerged in the first 6 months of this year is combined renewables in Germany have now overtaken fossil fuels for the first time. So for the first 6 months of this year, 57.7% of German electricity has come from the combination of the renewable technologies. Germany's always had a significant anti-nuclear or green lobby. And you saw that being reflected in 2002 amendment of the Atomic Energy Act there, which limited the lifetime generation from each unit in the German fleet. Policy was then changed again in 2010, which provided life extension for some existing units. And then as a result of the Fukushima event in 2011, that put an end to all of that, and they legislated faster phase out. And in April 23 this year, the last of the 3 plants were taken offline. Prior to March 2011, prior to Fukushima, 25% of electricity generation came from 17 reactors in Germany. And as I said, German government policies have really flip-flopped as a result of the need to have coalition governments with the Greens, which meant nuclear was on again, off again, example. And even in the recent past, there was some discussion around the fact that the Russian war had caused the gas shortages, and they were looking for a temporary stay of execution on those last 3 reactors. But as I say, all 3 plants are now offline. Currently, Germany still relies heavily on imports from neighbors as well, notably coal generation from Poland, and it also has its own lignite and hard coal stations which are running, which on the map in terms of where generation is consumed and where it's generated, makes Germany one of the worst CO2 offenders in Western Europe in terms of consumption. I'd like to go to the red dot, which you see there, which is Neckar-Westheim. That's on the Neckar River in Baden-Württemberg, and it was operational in 1976 with 2 units. First unit was 840 megawatts, and the second was 1400 megawatt pressurized water reactors. It was often the target of the nuclear lobby, but always had a very safe operating record. And the units still had many years of economic life in them, and they had been maintained in excellent condition at the time they were shut down. A little interesting aside is the German operators and the owners of those plants have been successfully suing the government for losses incurred from the premature political decisions to shut down the plants there. So moving to takeaways for South Africa. I mean, clearly public opinion puts a lot of pressure on the politicians, and you've seen that can lead to termination of the operation of perfectly safe and operable assets that still have many years of economic life left in them. And additionally, the climate change goals for the country have been severely impacted due to the increased reliance on fossil fuels again. So in contrast to Germany, China's had a rapidly expanding program. Let's go there, Andy.
Thank you, Peter. Before we look at the Chinese nuclear program, let's just look at each of those red dots on your screen. And each of those are new major coal-fired power plants built in China. That contrasts and compares with what you see now on screen. Each of the purple markers is a nuclear plant in operation or under construction in China along the coast. China, in fact, Peter, has 55 operable nuclear reactors with a combined capacity of 53 gigawatts. And between them, they generate about 5% of the country's electricity. But the country by far dominates the market for renewables. There are 21 reactors under construction in 2022. Most of them are pressurized water reactors, but China is actively exploring other reactor technologies, including advanced pressurized water reactors, high temperature gas cooled reactors, and fast reactors. And China is now marketing the Hualong 1 for export, largely an indigenous Chinese reactor design. And the impetus for building these nuclear plants along the Chinese coast comes from the need to improve urban air quality and reduce greenhouse gas emissions. Let's visit 2 of those. Let me just go back in the south, Yangyang, and in the north, Shidao Bay. And Yangyang that you see below you is the largest nuclear power plant in China, operated by the China General Nuclear Power Group. Sits in Guangdong province, and there are 6 pressurized water reactors, each of 1,000 megawatts. And together they are now one of the formidable nuclear plants in the country. And I'll come back to the lessons from that plant. Also take you to the Xidaobei high temperature gas cooled pebble bed modular reactor that you see on screen. And the China's Huaneng Group has just commissioned the 200 megawatt reactor 1 at Xidaobei, and it now feeds into Shandong province with great pride that they've commissioned the world's first pebble bed modular high temperature gas cooled reactor using helium instead of water to produce power. And I would say for South Africa, from a very extensive nuclear program in China, there would be 3 takeaways. The first one, that China, to achieve economy of scale, builds at scale in 6-pack configurations to lower those costs. Secondly, that the first high temperature gas cooled SMR has been successfully commissioned, and that China is beginning to export nuclear technology with the most advanced progress in Pakistan, and now also pursuing other markets. But the story just across the East China Sea is quite different, Peter. In Japan, tell us about the troubles of the Japanese nuclear program.
Right. Electricity production predominantly today in Japan is from fossil fuel imports, largely LNG, but also coal and oil are still being imported for generation. They have 33 operable reactors, which have a combined capacity of 31.7 gigawatts. And those are owned and operated by 11 different operating companies across Japan. They have only 11 of the 33 operable reactors are running now after Fukushima. And there are another 14 that are in various stages of restart or under regulatory consideration for restart. At the height of power generation from nuclear in Japan, 30% came from nuclear reactors. But today, with those 11 plants running, only 7.2% is coming from the nukes. I'd like to just talk about the plants there. You know, they were an early adopter of nuclear. The first plant was up and running in 1966. And unfortunately, after that Great Eastern Earthquake in March 2011, which caused the sort of infamous Fukushima Daiichi problems, all Japanese plants were taken down and off the grid in the subsequent 24 months. Public resistance was very strong after 2011. However, the government is still promoting a significant nuclear share. And METI, their sort of energy regulator, wants carbon neutrality by 2050. There have been significant safety upgrades costing many billions of dollars on the plants that they want to bring back. But local public opposition continues to delay restarts in many of those areas. You rely on the local governor in the local prefecture to actually agree to the restart, despite the regulator agreeing to it. An interesting aside is the regulatory failures contributed to Fukushima in a big way. And that resulted, after the analysis of the event, in a complete regulatory overhaul. And as an example, some sites' seismic design bases are now 3 times higher than they were the previous regulator. Japan continues to be an active leader in advanced nuclear tech, looking at fast breeders, small modular reactors, and so on. I'd like to go to Kashiwazaki Kariwa. It's on the west coast, the opposite coast to Fukushima, and it has 7 boiling water reactors, 8.2 gigawatts of installed capacity, which makes it one of the largest sites globally for nuclear power, and it's owned and operated by Tokyo Electric Power Company. Units 1 to 4 are on the 4 dots on your right-hand side, and 5 to 7, a later design, were on the left-hand side. What's interesting is in 2007, there was an earthquake offshore as well on this western side, and one can consider that to be a precursor to Fukushima, and that resulted in significant damage to the plants, the infrastructure, and all of those units were taken offline for something like 21 months. And units 2, 3, and 4 had not yet been returned to power by the time that Fukushima happened in 2011. And as I said, despite the Kashiwazaki Kariwa earthquake being beyond the design basis, my view is that there was quite broad regulatory apathy, and Japanese seismic regulations were not challenged at the other sites. As we stand today, Tokyo Electric Power has failed to get approval to restart these reactors. And as I said, they've had very expensive post-Fukushima upgrades on those sites. Let's go across to Fukushima Daiichi. 6 boiling water reactors on that site, also Tokyo Electric Power Company, and units 1 to 4 on the left-hand side, and 5 and 6 are those on the right. There was that earthquake offshore in March 2011, which resulted in that huge tsunami, and that knocked out both the on and off-site power, leading to partial core meltdown and some hydrogen gas explosions in some of the reactors. Classified on the inner scale as level 7, which is the highest level, and that's only been equaled by Chernobyl. Local communities were really devastated by the tsunami itself, but additionally, about 150,000 locals needed to be evacuated from the surrounding area due to the radioactive contamination from the hydrogen explosions. They're still struggling with significant volumes of radioactive wastewater which are being generated. Something about of the order of about 300 tons a day are being generated on the site, and you can see in the background of that picture literally hundreds and hundreds of storage tanks which have been used to contain that radioactive water. It's now being discharged to the ocean, but not without controversy. Obviously, Fukushima caused a huge knock-on in terms of global impact. The German phase-out was a really good example that we spoke about, but also every single country undertook quite significant upgrades to plants across the world. The sister plant at Daini also is shut down, which adds to the economic woes of TEPCO. So let's just look at the takeaways. Japan is energy resource poor, and they had an initial investment to get up to 30% of nuclear generation. And replacing this post-Fukushima has been, quite a big financial burden on the country and seen tariff increases for the public. And I guess probably the biggest takeaway for all of us is the cost of getting nuclear safety wrong is enormous, and it requires significant state intervention to sort out the aftermath. Current cost estimates for decommissioning Fukushima are about $200 billion. I'd like to move...
Peter, let's just go to India.
Right.
India has both a military nuclear program and a peaceful nuclear program. And let's, for a moment, just look down on India and firstly observe that this country is run on coal. Nuclear is, between those plants is only 3% of its generation. And you can see the Narora, the Rajasthan, the Kakrapar, Terapur, Kaiga, Madras, and Kudankulam plants, which we'll visit in a moment. And those 19 commercial reactors with 8 more is part of under construction, is part of a very carefully designed 3-phase nuclear program in the country, where the first stage involves pressurized water reactors fueled by natural uranium, and light water reactors which produce plutonium. And then the second stage that India is planning is to involve fast breeder reactors utilizing the plutonium from the previous stage to breed U-233, and also from the thorium reserves. And the third stage is to have involved very advanced heavy water reactors, specifically to use the U-233 from the previous program, which will give India, in their view, essentially unlimited power supply. Let's visit one of the newest power plants in the country, right in the south in Tamil Nadu, which is Kudankulam, that you see here on the border of the Indian Ocean. It was built under an agreement with the Russian government. It employs advanced Russian VVER-1000 technology, which, as I said earlier, is a pressurized water reactor. And the first two operational units will contribute 2,000 megawatts to India. Quite controversial in many ways in a country which is a divided, noisy democracy, about safety, about environmental impact, about impact on local populations, etc. But the Indian government is very clear that it is going to expand Kudankulam. You see the two reactors, the two red dots in the back, and the cold water inlet in the front. For me, the takeaways for South Africa from India would be that it is possible to slowly build indigenous nuclear power industry, but you need scale to do so. The second one is that importing uranium for enrichment is difficult if the country is not a signatory to the Nuclear Non-Proliferation Treaty. And the lastly, that as far as nuclear power is concerned, it raises three questions about where does your uranium come from, where is the enrichment going to be done, and what are the limits on the export of nuclear technology from your country. Peter, could you summarize for us the overall picture in the world as far as nuclear generation is concerned?
Right, you can see the global production chart over there, and you can see the relatively steady growth between 1970 and 2000. That growth has stabilized after 2000 as existing plants enter life extension, as older plants are shut down, and as newer plants have come online. What's interesting to see is that notable drop-off in the Asian plants, which is that bottom light blue area after Fukushima, and the subsequent Asian recovery is fueled by Chinese growth and some of those Japanese plants returning. So looking at global takeaways for South Africa, at the moment we have 37 countries producing 10% roughly of the world's electricity from 436 reactors. And there have been three industry shaping events: TMI, where there was a partial core melt but no radioactive release, so containment building worked; Chernobyl, which is the worst event in '86, 31 direct deaths attributable to the accident, and United Nations talks about another 4,000 deaths over the lifetime of some people who were exposed. We've had Fukushima, which we've spoken about. The tsunami caused 15,000 direct deaths, but there was not a single death directly attributed to the plant failures themselves. So in terms of public impact, very small numbers compared to those attributable to combustion of fossil fuels, but public opinion has nevertheless been impacted, and further accidents in the world will increasingly contribute to the fragility of that public perception. And the net result really has been nuclear power has flatlined for the past 2 decades. So Andy, let's wrap up by looking at new entrants.
Peter, let's visit a few plants in the United Arab Emirates, in Egypt, Bangladesh, Turkey, and in Belarus. And let's first look down on the Mediterranean coast, just west of Alexandria, at the El Dabaa nuclear power plant, the only one under construction right now in Africa. Egypt is a country, most of its energy comes from natural gas out of the Mediterranean. And the El Dabaa nuclear power plant is Egypt's first nuclear power plant designed for a total capacity. You can see the first two reactors there where the red dots are 4,800 megawatts. Those are the first two 1,200 megawatt reactors. It's a result of an agreement between Egypt and Russia and the Russian State Nuclear Corporation. Rosatom is the primary contractor who does the construction, the operation, the maintenance, and the decommissioning of the plant. And Russia has also provided a significant portion of the funding required for the construction of the plant. And let's just take a closer look and zoom in. That's what a big Egyptian construction site for nuclear power looks like. Next, we go to the United Arab Emirates. And Peter, we've both recently spent considerable time in the UAE. Tell us about Barakah that you've been so closely involved in. Was it successful?
Right, Andy. The UAE still predominantly relies on its own natural gas, but it embarked on a nuclear build in 2012 at that Barakah site, which you see in the Emirate of Abu Dhabi. And the owner of the plant is Emirates Nuclear Energy Corporation, and they are building 4 Korean APR 1400 units at the site, 3 of which are already in commercial operation, and the 4th is slated for fuel loading later this year, and it will be fully commercial in 2024. Constructor was KEPCO, a Korean company, and I think they can be justifiably proud of the schedule of what is their first major export project. The units came online, units 1 to 3 particularly followed very closely on each other's heels, and very well done project. Once fully commissioned, the plant will have a capacity of 5.6 gigawatts and will reduce the country's carbon emissions by 12 million tons a year. The site is slated to contribute about 25% to the country's electricity needs. And this is the first nuclear project in the Arab world. And that was really made possible by accession to all of the international nuclear treaties. And the IAE and the UAE has committed itself really to not to enter the world of uranium enrichment, and pledges to pursue a peaceful nuclear program. Just at the Baraka site, there's some thought of using the site for desalination and hydrogen production as well.
We next quickly travel to Bangladesh, which also right now is fueled by natural gas. The only nuclear power plant is the one that you see below you under construction. It's called the Raipur. Been under construction since 2017. The 2 units that you see where the red dots are will have 2,400 megawatts of capacity. Russian designed, the same VVER reactors are being built by Rosatom, and it's expected to be completed next year. And that's a more up-to-date picture of what that site looks like. And you can see the 2 reactors where the red dot is. We also traveled to the former Soviet Union, to Belarus. And here you can see the Ostrovets nuclear power plant in western Belarus. 2 of the same 1,200 megawatt VVER Russian reactors began in 2013. First one came onto the grid in 2020, and the second one is being commissioned right now. And our last visit would be to Turkey. And we looked down on the Mediterranean coast of Turkey to a place called Akuyu. Turkey's power system is based on natural gas. Nuclear today is 0% of that. But the 4 units, each of 1,200 megawatts, being planned here with Russian reactors, Russian designed, being built by Russia for Turkey. Construction began in 2018, expected to be completed in 2026, when it will supply about 10% of Turkey's electricity needs. So if I were to close and say, what are the takeaways from the global new build? That a significant number of countries, including emerging powers, are considering nuclear power, often for greenhouse gas reasons. That emerging nations are building nuclear power with support mostly from Russia, and that the energy world awaits both SMRs and advanced modular reactors to eventually bring the cost and schedule benefits of modular construction to reduce investor risk and the price of nuclear power. Just before we leave, we've not been to Australia. That's the one continent without any nuclear power plants. It runs its power system in the main on coal. Australia's position on nuclear power is complex and has evolved over time, but there are no plans to build any of the any nuclear plants in the country. The government maintains a ban on nuclear power, and that's despite the fact that the country is the largest resource holder of uranium, and you see the 2 big mines at Olympic Dam and Ranger that export uranium from Australia. Before we hand back to you, Professor, as moderator, we go to Oxford, to our world in data, and I'm sure everybody has seen this picture that looks at world energy supply from 1910 to today. And you can see the slivers of traditional biomass at the bottom, coal and oil and natural gas. And the next one where that red dot is nuclear, which contributes about 4% of daily global primary energy. And above that, we see hydro, wind, and solar. Against that background, thank you for your attention. Thank you for allowing us to take you on this global tour. And we go back to where we started, to Koeberg. Back to you and the panel now, Professor.
Right. Thank you very much, Andy and Peter, for a very informative visit. I thoroughly enjoyed it, and there was quietness in this room as well, so I think it was also enjoyed here. I also want to acknowledge Professor Bismarck Diobeka. Thank you very much for surviving the Stellenbosch traffic, but welcome that you are here. Can the panel please come and take their seats? And while the panel is taking their seats, just for the online audience, we will open the Q&A block soon, and we will inform you when that's open, and you can post your questions there. But it will also, we will allow online participants to put up their hands, and they can actually ask their question in person as well as we will allow the people here. But if you have questions, write them down, and we will give you an opportunity to post them, or Professor Craig McGregor will post them on your behalf. So, as I said, we've got the panel here of Professor Bismarck Diobeka, Professor Mark Swilling, and Ms. Jessie Burton, and they come from different areas. And as I said, the bios are available. So I'm going to start off, Professor Diobeka, and I'm going to pose the first question to you. And that is, how do you see the future role of nuclear power stations to provide electricity to South African national grid? And in your opinion, I mean, which are the main drivers and which may be the main barriers for such an power station or power stations?
Thank you very much, Prof. Vikas, and good afternoon to the audience and to my fellow panelists. Apologies for being a few minutes late. I misplaced my car keys. So, indeed, South Africa is not new to nuclear, as we all know. Not far from here, we have a nuclear power plant in Koeberg. And it has provided very reliable electricity to the Western Cape and for many years. On top of that, we have not had any major incidents in the Koeberg nuclear power plant, except for the Bolt incident that we know, which didn't pose any threat to nuclear safety. So therefore, South Africa is not new to nuclear. But what are the drivers? The drivers first, I think, is a demand. I don't have to overstate the headaches that we have about load shedding. So therefore, there is a huge demand for electricity, and we cannot discount nuclear as one of the contributors to quench that thirst for energy. But linked to that is the aspirations for us as a developmental state. If we are to meet our developmental objectives as espoused in the NDP 2030, definitely we can't take away, divorce nuclear from those aspirations as part of the contributing generation sources, in particular for baseload. Thirdly, our decarbonization targets. I can't imagine a future of us decarbonizing without the contribution of nuclear energy. If we are to meet our obligations in terms of the Paris Agreement, we definitely have to consider nuclear as being part of the grid. So it's a drive, that's another driver. And lastly, security of supply. We know what happened in Ukraine after the war started. All Europe went cold because the Russians shut down their gas. And then you have a big problem there. So we need to, at all times, make sure that we're self-sufficient as far as the security of energy supply is concerned for the country. Yeah, those are the drivers.
Thank you very much. So Jessie, we heard that this is going to make some contribution. What is your take on how nuclear power can mitigate climate change?
Sorry, I need a computer in front of me because I've got lots of numbers to throw at you. So thanks for bringing that up, because I think we all know climate change is one of the most critical challenges facing the world today. We are looking as a world like we need to reduce our emissions by around half by 2030. The budget for 1.5 degrees, the goal that was agreed in the Paris Agreement, will be finished in 4 years' time. So we have a huge investment challenge and a challenge of shifting our techno-economic systems, and all of this must also happen alongside, of course, addressing poverty and sustainable development. Clean energy, so renewables and nuclear now accounts for most new electricity investment in the world. Africa is being completely left behind. We are not investing to keep up as we need to, but the world is still moving much too slowly for that 1.5 degree target. And the energy system is very critical to this. So electricity itself is around 1/3 of global emissions, and it's one of the sectors in which we have cheap and affordable and commercially viable alternatives to the existing fossil fuel system. This is much even more difficult in the South African context, where energy is 80% of our emissions, and the electricity system is almost half. And the reason we need to focus so much, and I'm sorry because I'm going to get to nuclear, the reason we really need to focus on this in the South African context is that, one, we can address those immediate emissions on the supply side, but in the long run, moving towards net zero emissions, towards the kind of global targets that we need to get to for 1.5 or 2 degrees, you also need to be able to supply clean electricity to end users. So we need to be able to electrify transport and electrify industry and that sort of thing, and meet poverty goals. So at a global level, what do we see? What is the role of nuclear in doing this? And I'm sorry, I'm also going to compare it to other technologies because I come from an energy systems modeling team, and that's what we do. But so in global modeling that looks at these kind of net zero scenarios, the IEA, for example, are one of the very strong, the International Energy Agency, and they're projecting that nuclear will grow from just over 400 gigawatts of installed capacity to just over 500 in 2030. Very similarly, IRENA sees a very stable growth, very small and stable growth in nuclear, so it will still provide around 10% of global electricity in 2030 in these 1.5 degree scenarios. And that sounds like a lot, but the renewables need to grow from 3,600 gigawatts to 10,000 gigawatts at the same time. We need to move from around 300 gigawatts to around 1 terawatt per year by 2030. So the kind of, nuclear may have a role, but it's a much smaller role. It's only 6% of the role that renewable energy would be playing in that same time period. I'll stop there. I've got lots on the South African modeling as well, but we can come back to it.
All right, thank you for that. Mark, maybe you want to continue in giving us your ideas of how does nuclear power compare with other technologies from a cost perspective?
Well, although I'm a professor here at Stellenbosch University, I look at this from the perspective of the Development Bank of Southern Africa, whose board I chair. And as you all know, we're a very large investor in infrastructure. 20% of our book is in renewables, and 20% of our book is in Eskom. And we have big exposures to the big metros, which is largely energy. So we're effectively almost an energy bank. And so if I look at energy, nuclear, the prospects for nuclear infrastructure from an investment point of view, there's a lot of concerns, especially around costs. As we know, if you compare the cost in terms of kilowatt hours, wind and PV are roughly 2 to 8 European euro cents. Gas is 8 to 13. Coal is 10 to 20, depending on what kind of coal, and nuclear is 14 to 19 cents. Now, everything depends obviously on your capacity factors. The higher your capacity factor, the longer your life, the cheaper nuclear is going to be. But those kinds of numbers are of major concern from an investment point of view. If you look at the problem of overruns, as the Department of Energy study has shown, looking at 75 nuclear reactors built between 66 and 77, the average overnight cost was 207% higher than the original estimated cost. And MIT has just published an article in 2020 in the journal Joule, where they looked at 5 decades of data, and they compared the nth of a kind costs to the first of a kind costs, and you would expect a decline in costs because of learning curves, but there isn't. And that's got a lot to do with the overruns, and they calculate that 50% of the overruns has got to do with soft costs, which has got to do with design faults, rectifying construction problems, and project mismanagement. And it's this that has been a key driver for SMRs. And within the financial circuits, there has been interest in SMRs. But that has really been called into question by what's happened to NuScale's 462 megawatt plant for Utah municipalities. The estimate in 2016 to 2020 by NuScale was that it would cost $55 per megawatt hour. In 2020, that went up to $58 per megawatt hour, and in 2023 now it's $89 per megawatt hour, which would be much higher if it wasn't for the $4 billion subsidy. And this assumes a capacity factor of 95% from the beginning, even though no nuclear plant has ever been that successful. And if you look at the project cost, which is about it was 5.3 billion, now it's 9.3 billion, that's roughly $20,000 per kilowatt hour, which is not that different to Vogel in Georgia, when SMRs were supposed to be cheaper. So I think when I think of this take into account these kinds of factors from an investment point of view, in South Africa, I don't think we can assume that the fiscus has got capacity. It's unlikely that there's going to be much trust in the capacity of the state, given the governance challenges, and the flow of capital from international, but more importantly, domestic sources, is primarily into renewables. And the reason why the price of renewables has been able to drop so fast has been because of fabrication. It has been possible to mass produce the primary components of renewables and deliver them to site. That's what SMRs are supposed to be able to do, but even NuScale has backed away from its initial claims that it would be fabricating and delivering to site. So I think from a financial point of view, at this stage, especially in the South African context, the business case is not convincing.
Right, I knew we were going to quickly get into the money, so I want to just pull us back a little bit from the money, because we are engineers, professors. So I'm going to give you the opportunity to just let's dream a little bit on. So if we were to build nuclear power stations, what capacity do you think should be built? 2 gigawatts, 10 gigawatts, and if you pick a scale, where should that scale be? And perhaps refer back to some of the lessons that we've learned this afternoon on our nuclear power tour.
Well, it's not for me to thumbs up how much the capacity would be, but it has to be based on government policy. And at this point in time, the policy prescribes so far in terms of the IRP, the space for nuclear in the mix would be 2,500 megawatts, so that's 2.5 gigawatts. And you can divide that as you wish. It can very well be 2 big conventional plants plus maybe each of 1,000 capacity, and perhaps share the 500 megawatts that's left for SMRs. As the Prof said, SMRs, in spite of the gloomy cost projections, SMRs present a very, very good opportunity also to mitigate against capital investment in as far as nuclear is concerned. Take a case of a small town in the state of Wyoming in the United States, a small town called Camera, where the TerraPower company, Bill Gates, and GE Hitachi have signed up to deploy a reactor design called the Natrium reactor, which is essentially a 375 or so thermal output based on sodium fast-cooled reactor technology. Now, coming back to the topic of this seminar being the just transition, just energy transition, if you look at that Wyoming case in Camera, the population there depended mostly on, coal-generated electricity. And now the transition, because Wyoming is one of the biggest guzzlers of coal-generated electricity. And now that is dropping because of the decarbonization requirements. But the transition there, one of the coal plants that's going to be shut down and be replaced by natrium reactor would be a very nice, fitting into the not disrupting the economy there. So the transition would be smooth, because that coal power plant, we are told, was employing 110 people. It is projected that if we deploy these natrium reactors in Camera, you'll be in fact employing 200 plus people. So you're not displacing jobs. That's also very important. But also the issue of skills. People, if you look at the coal power plant, the most part, the difference between that and the nuclear power plant really is the heat generation source. Beyond the steam generator, everything else is similar. The turbine, the switchyard, and so on. So the skills that you use in those coal power plants for the primary circuit, the secondary circuit, would really be usable again. So there will be no job losses. We need to therefore look deeply into the possibility of deploying SMRs in the just energy transition to replace the coal power plants in Mpumalanga. So take Mpumalanga province as our Wyoming in this country. Therefore, you should be able to deploy some of these SMRs in those inland sites of nuclear power plants, of coal power plants, without really displacing jobs, but also developing new industry for the production of these components. So there are opportunities there, notwithstanding the issue of financing and costs, as the Prof has said. Now that needs to be looked into very closely, and a number of options must be looked at, financing options, to ensure that it is not unaffordable to the taxpayers. Indeed, looking at the fiscus alone is definitely not a no-go. You can't. Our socio-economic problems as things stand are so insurmountable. Are so insurmountable that you can't actually risk exposing the fiscus to a new build alone. So we must look at possibilities of, as the Minister of Energy has said before, looking into opening up the space for private sector and public-private partnerships, and see how we can come up with financing options.
Okay, before we're going to go into that, and I'm actually going to pose that question also to Mark, so if we are going to build, how could be perhaps structured. Just one correction, the IRP doesn't speak about 2.5 gigawatt of nuclear. It says in a footnote that the 2.5 gigawatt of Inga could be replaced by a nuclear. So the models didn't put nuclear in the IRP. That is just a small technicality which I think we should acknowledge.
Okay.
Okay, but Jesse, Professor Teobeka now talked about the just energy transition. So I actually first want you to just tell us, what is a just energy transition, and why do we need a just energy transition? And then if we understand that, what could be the role of a nuclear build in South Africa for the justness in our energy transition?
Sure. So I like the phrase just transition, because I think if we only focus on the energy sector, we sometimes lose a lot of the impacts from the energy sector on communities or people who live near power plants, for example, and also the impacts that will happen to regions or towns as some of these fossil fuel assets close. But the just transition is really, it's kind of entered the discourse through the Paris Agreement and through the union movement and the environmental movement to say, look, as we manage this energy transition, as we transition into a low-carbon society and economy, we need to look after people and protect them in that process. And it has got various ways of being understood, and some of those are forward-looking. So it says we need to have good, decent jobs in new manufacturing sectors. We need to skill people, that kind of thing. And then it also has a sort of backward-looking component, which is to say, where people are going to lose their jobs. We're going to support them to relocate. We're going to retrain or reskill them. We will help them with retirement packages, for example. And it has, up until now, been very heavily focused on workers, but increasingly it includes local communities who are already facing impacts. Some of the forward-looking aspects are really interesting in the South African context, like community ownership of renewable energy, for example, or community ownership of other kinds of productive assets. Now, the South African Just Transition Framework is very interesting because it has different kinds of justice in it. We're a global leader in this for developing countries, and it also says we're going to look back at historical injustice and we're going to fix it in this process. And so there's a lot of work that's gone on, especially around coal plant closures. There's been a very heavy focus on coal plants closing, on how to repurpose them, how to retrain people. But of course, we also need to look at that entire value chain at coal mines, how to repurpose coal mining land that has been abandoned. There are 800 abandoned coal mines in Mpumalanga. And you need to also think about the regional and local economies in towns like Emalahleni, where almost half of the people are linked to the coal sector in some way. So that's the just transition part. And of course, thinking about those different opportunities in these spaces is completely critical. It's absolutely critical as we look at this retirement schedule that Eskom has in place, to look at each of these sites, to look at the plants, to see what they are able to do. Are they in good shape? Could they be repurposed for power and repowering? Is it something else? But that hinges a lot on whether, in fact, nuclear is the best option, and it may be site-specific, but it's also about the national energy system. And I'm sorry to come back to costs, but this is really critical. We have multiple modeling teams in the country who, the approach to energy systems modeling is not to tell the model what to build. You offer all the technologies and the way that they run when the sun isn't shining and the wind isn't blowing, and you have a set of energy services that you need delivered, and models are designed to deliver that in the most elegant way possible. And in all of the modeling exercises that we've done in South Africa, nuclear is not part of that solution. And this is really important. The NBI's work on this has shown that if you did have a big nuclear build, go hard the way some of the other countries have done, our electricity system cost will be 16% higher. And that has really important justice implications, because that impacts how people can afford electricity, whether our energy-intensive industry can survive. And it soaks up capital that we really need to be allocating in. You only have one. I just read a great paper about this today. You can only spend each dollar once. You can only spend each rand once. So you need to put that in the place that's going to be most effective.
Thank you for that. For our online audience, the Q&A is now open, and you're welcome to start posting your questions there, and we will pick them up from there. Mark, you want to continue that narrative around justness, or you want to add something to what Jesse said?
Well, I think just transition, the notion of just transition is used in 4 ways in South Africa, briefly. One is get renewables online as quickly as possible for the sake of economic growth, so that trickle down can follow and you can create jobs. So that's quite a few banks have articulated that position. The second one is decarbonization with social mitigation. In other words, interventions to deal with the consequences of coal closure. The third is that plus upstream industrialization, which is a bit where the Just Energy Transition Investment Plan has now moved the needle. And then the fourth is post-capitalist economic transformation. Those are the 4 articulated by the unions. Those are the 4 kind of frameworks of what just transition means in the South African context. As I said, the dial is shifted with the cabinet approval of the Just Energy Transition Investment Plan to the third position: decarbonization with social mitigation plus upstream industrialization, using local content interventions to make sure that we actually build the stuff ourselves rather than import it all from China. But this again has massive investment implications. The biggest blockage to all of that now is the grid. So as we saw from Bidwinter 6, there is very limited capacity on the grid, and all the 30 gigawatts of renewables in the pipeline and possibly new generation capacity from gas and nuclear is all going to come up against the grid constraints. And the massive amounts of investment that are going to be required to enable the grid to withstand future growth in generation capacity is now a big focus. And the Minister of Finance opened the door in February during his budget speech to concessioning pieces of the grid. So that could result, for example, in the opening up of the Northern Cape grid for public-private partnerships and the mobilization of investment, not off the fiscus, but from private sector sources.
Right.
So that's going to be an absolute key for the just transition. There's no any form of transition without that kind of investment.
Right, thank you for that. Marley, they say that the Q&A is not open. We are working on that, right? Okay, so the Q&A is open, online colleagues, and they are receiving questions. I want to come back to the point you made about, I think it was Wyoming, right? Mm-hmm. So in order to participate in such a nuclear program, we need skills, right, in South Africa. So in your opinion, what is the current status or state of the South African nuclear industry? And if we do embark on this, how quickly will we be able to ramp up and provide the skills? Or will the Chinese just come and build next to Koeberg or at Tuispunt?
Thank you. I think let me start. I just want to comment on the issue of cost again. I think what my colleagues are saying here, my fellow panelists, about the cost of nuclear and how expensive the business case, I'm not sure if we are taking into consideration the fact that if we build these plants and project them to live for between 60 and 80 years, does that still remain the case that nuclear is the most expensive? Because we know, as we speak, that in the United States, for example, you have plants that are running, that have just gotten, in fact, life extension to 60, and some of them 60 years, and some of them projected, in fact, to get to 80 years extension. So if you think about that, you definitely amortize that cost of building the plant very early at around 20 to worst case scenario 30 years. After that, really it becomes a money printer. So I don't know if we have taken that into consideration. But coming back to the question of skills, it is true that skills can be a showstopper, especially given the current situation where you, in fact, have a very high demand for nuclear skills worldwide. We know that one of the biggest problems that caused issues at our local nuclear power plant, Koeberg, was attributed to the skills shortage and the skills exodus, actually, and mostly to the UAE. My friend Dave Nichols is in the audience here, and he was one of the people that went to the UAE to talk to the UAE and say, hey, if you keep poaching our people, you must know that you are exposing us to risk, and if that happens, if something happens to that nuclear power plant because of you taking our skills, you are in fact causing a big problem for the entire nuclear industry globally, because an accident in one is an accident in all, as we know from Fukushima. So skills are critical. And the thing is, you can't continue training people, building capacity for them to do nothing, right? So you hear young people nowadays saying, well, nuclear is a dying career because I studied today for my nuclear engineering degree or something, and ultimately I don't get a job, or chances of getting a job are very slim because there's no industry. So the issue of capacity building is very linked to what the future holds. Otherwise, we train mechanical engineers and electrical engineers that can be used in the power industry, not specifically to nuclear, which is okay. But at some point, we need to nuclearize these people. Studies have been carried out, I think, by NIASA, yes, the Nuclear Industry Association of South Africa, years ago. And in fact, they have found that we are not very far from having the skills that we need to start a nuclear power program. But that was then. That was before we had a mass exodus to the UAE. And of course, there's new built in England. I know people that have left the country to go and work there. There will be new built in Saudi Arabia, probably. And there's very good appetite for people to leave the country and work there. So the sooner we decide and get on with it, the better. Because universities cannot invest in these programs when there are no takers at the end of the line. So currently, the Northwest University and maybe WITS, there are very few universities that are training in the nuclear area. In fact, in the whole of Africa, I know us in South Africa, Northwest, I know the University of Alexandria in Egypt, the University of Ghana. That's just a few of them. In nuclear, I'm talking nuclear power engineering programs. So the skills are a very serious showstopper, but that depends, again, on the uptake. You can't train people to just, otherwise you're training for export, which is also not cost effective. You're exporting skills.
Okay, thank you. Jesse, you want to take that part, you know, that nuclear is cheap if we look over 80 years and not only 20 years. I mean, does the models in any sense account for that? Is it included?
Yeah, so I mean, this is why you have systems models rather than talking about LCOE, for example, because all of those costs over the lifetime of the plant and all of the power over the lifetime of the plant are accounted for. I suppose it's an interesting question if we start extending the model horizons to 2100 to think about this, and then we would need much better costs on the life extension costs, for example. And so, I mean, one of the challenges is how much is it going to cost to extend the life of Koeberg, for example, because we can put that in our model, but we would need to know that. But I want to add on the skills thing. I think this is a bigger problem. I mean, I'm sorry, it's all about nuclear tonight, but we're going to be investing R1 trillion in the power sector over the next 7 years. We have a huge shortage of skills in all kinds of engineering, and I mean, I think this probably needs, I don't know, a presidential task team or something. All of you very clever engineers sitting here to think about how do we actually deal with this. We're going to need demand-led skills at a huge scale. And that's something all the engineering schools need to be thinking about, I think.
All right, I can see there are many questions online and also some hands going up here, but we're going to finish the panel discussions and then we're going to get to the questions. So I'm going to wrap up because then we can have a wider discussion when we have other people participate. So Mark, I'm going to give you this final challenge, and then each one will have just a minute or so to make a final big statement. But let's say we decide we have to do it. The president says we're going to build nuclear, now we have to build nuclear. How will we do it? How will we be able to do it? Is there any pathway that you can envisage of how we can do that?
From a financing point of view, I find it very difficult to imagine. I can't see, I mean, sovereign guarantees would have to be a key factor, I'd imagine. And I can't see that happening. I can't see state ownership being viable. I can't see, obviously, anything from the fiscus. And so the question would be, to what extent would you be able to put together the international and domestic funding for a large-scale, capital-intensive program like this, especially in light of the fact that a large majority, nearly all the big financial institutions, both public and private in South Africa, have made, in the last 12 months, major strategic decisions to allocate capital to the energy sector, but not into nuclear. So I can't see that. I mean, that's a flow. That's a momentum that is driving. The only big player that hasn't really made a substantial strategic commitment is the PIC, and they hold 80 billion of the Eskom debt and are, you know, the biggest asset manager, and, you know, maybe a player like that has got the kind of leverage to kind of shift the directionality of investment. But overall, I find it difficult to see, from a financing point of view, institutional governance point of view, and a skills point of view, that it's a viable option. There are those who argue that you need SMRs to interact with the renewables-based sector, the load following argument. But if you build SMRs that are load following, to counteract the variability of renewables, your average EAF is going to go down. and that is going to push up the prices. So just take NewScale, for example. They're assuming $89 per megawatt hour at a 95% EAF. If that drops to 75%, the price goes up to $141. So that's the risk of that solution that is being advocated as a way of supporting renewables.
Right, thank you. So to wrap up the panel discussion, Jessie, any final thoughts?
I mean, I tend to agree with Mark a little bit. I suppose I would say to the president, hold off and let's see if the modularity unfolds, because that will, if it delivers the cost reductions that it claims it will, then we may be facing a very different situation in the 2030s. And the advantage of this is that we could have the flexibility at that time to do it. And the other thing I would say is, unless the risk is not carried by us as a country, which is quite unusual in the nuclear financing, as we saw above, it's not viable for us to take on cost overruns, time overruns, expensive financing, etc.
Right, thank you. Professor Theo Baker, final thought?
Yeah, I think what you say about the president saying we're doing nuclear, I wish he could say that. You see, my problem is, if you go back during the times of President Mandela and you take the nuclear story of the country, when President Mandela came in, he was more concerned about nuclear disarmament and non-proliferation, and he managed to solve that problem. And we're back into the world stage. Then came President Mbeki, and President Mbeki quickly caught up with the idea that we need to increase our capacity and also building new nuclear power plants. Hence, his big support for the PBMR project. Unfortunately, before he could see it through, he was out. You had President Zuma with 9.6 gigawatts plan, which unfortunately also could not go through due to process issues. But then came President Ramaphosa. Now, I've been following his SONA addresses, and I don't ever remember President Ramaphosa mentioning nuclear in his SONA. So the question then becomes, is the current dispensation saying no nuclear? If that is the case, then it must be clear. So that it's clear for everybody that nuclear is off the table. But if we keep on, we're no longer, that hesitation, that vacillation is really wasting everybody's time, and it's eating up a lot of resources. So I wish there can be clarity on the way forward, tone from the top, to say, are we going nuclear or not? If we are, there needs to be tangible steps.
Right, thank you for that. Mark, you have a final thought?
Yeah, I mean, I'm in agreement that a clear-cut decision has to get made. But we can't ignore the politics. What really does worry me is those who are pushing for a nuclear solution out of genuine engineering concerns, which is where you are coming from, are inadvertently also supporting a political agenda that worries me, which effectively is, let's be honest, and I've written about it, is a Russian deal. And a Russian nuclear plant is, somebody described it as a combination of an embassy and a military base. It's going to result in the tying of the South African economy to a global hegemon, which I don't believe is in our interests as a sovereign nation. So I think it's a threat to our democracy.
Right, thank you. So, colleagues, we're first going to take some online questions, just out of respect for our online participants. And Professor McGregor, do you have a good question there for us? Also, if you can state the name of the person, it will help, but otherwise, just pose the question.
So we have a question from Liz McDade. Liz, if you want to ask your question through online, you're welcome to unmute and ask your question.
I think if you can read it, you can just read it for us.
Okay, can you hear me?
Yes, we can hear you, Liz.
Thanks, thanks Vikas, and thanks to the panel. I just want to make like some very short points. Firstly, I think the first two presenters were quite disappointing. They sounded like a nuclear sales pitch. And I think if we're going to make an informed decision, we should be hearing like the risks and the challenges and the benefits. The other thing is, if we are looking at the life cycle, this is really my question, what about the decommissioning, the technology? So this is for the academics, the research, the engineering, for the waste disposal, for the decommissioning. None of that came up in the discussion, but that's a cost, and it's something that we need the skills to do. And maybe it's not as sexy as building a nuclear power plant, but I agree with Jesse, we don't know that those new things work. It's all experiments. So, but we have an existing problem, whether it's now or in 20 years' time, and we need to be able to keep our current nuclear things safe. As Chobeka said, one mistake, and it's a global mistake, and it will really be a problem.
Thanks a lot, Liz.
So for me, those are my questions. And I must just say that the Russian deal was a very big mistake, and it wasn't just a process issue.
And we still honor you for that, Liz. Okay, colleagues, I forgot. I was going to read the rules of engagement, and Liz slipped in. So the online participants are welcome to make the Q&A function, to use the Q&A function. They are also welcome to raise their hands, and they can ask the questions. The participants in the room will be given an opportunity to make use of the roving microphone so that the online people can also hear your questions. That's important. But this is the killer here, and this is where Liz actually slipped in. All contributions will be strictly limited to only 2 minutes, because there's a lot of people who want to say something. So I want you to really think carefully what you want to say, and you've got to say it in 2 minutes, and then we're going to cut your microphone. So please make sure you are short and succinct, so that everybody that wants to have a question or make a statement will have time to do it. Participants are welcome to make statements or pose questions to which the panel will react. No follow-up questions will be allowed until there are no more questions from other participants. And again, this is to give everybody an equal opportunity to participate. And we are all already dealing with the online questions. Okay, so Andy and Peter, you heard that you were good salesmen here. But do you want to respond to Liz's question about the decommissioning and the decommissioning cost and how that are accounted for in the cost of nuclear power?
Yeah. Peter, you go first. You're on mute.
Okay, Peter, you're on mute.
There we go. Thanks. Decommissioning costs are captured or gathered during the life of the plant. All countries have a decommissioning provision, which is set up to manage the back end of the projects. A lot of plants have been decommissioned or are in the process of decommissioning, so the technology is there. And it's improving as we go on. And as I said to you, for example, in the States, 41 plants are already shut down and have been through various stages of decommissioning as they are right around the world. So I think there's an obligation on the operators to gather costs for the back end and for decommissioning spent fuel and the wastes from decommissioning the sites.
Right, thank you for that. Craig, you want to nominate another online participant before we start going to the in-room participants?
I've got a good question here from Dr. Mate. He mentions the delays in the refurbishment and upgrade